Hello folks, welcome to Lester's. Randy, this is your Dave Made M400. Randy sent it in for me to upgrade the power wires on. It had 10 gauge power wires, so I pulled the old ones out and took the side of it off so that I could get the things a little better, and it looks like it needs a good cleaning, so I am about to go and do that. Okay, but it's got the Toshiba 2879s in it, 4 of them. This is an original Dave Made box. Okay, more to come. Okay, Randy, I cleaned some of the crud out of here. Looking a little bit better. Got a lot of that old solder flux out of there. I'm getting ready now to install the new power cables. I did spray it down with a light coat of 226. Hang on a second, I'll show you. It's CRC 226 electrical grade, improves electrical properties, lubricates and frees rusted parts, replaces moisture and stops corrosion. That was the big reason that I used it, because your copper and some of the components have started to get some corrosion on them, and so I gave it a light coat of that 226, which should stop it. Okay. Alright, let me get the power cables installed. Okay, got your new power cables soldered down. I ran the ground cable up here halfway of the ground plane on the board and soldered it down rather than having it right there at the back. That way your transistors will get a little more current. Okay, and I'll clean that flux up. Got the new power cable soldered down to that bus there. But I've noticed a few things since I got it cleaned up. This resistor right here is 4.7 ohm resistor. Has gotten hot. See how it's kind of brownish in the center? And this guy right here on your output combiner is practically burnt up. So I'm going to pull him out. See what the value is and replace it with a new one. Okay, all your feedback resistors look pretty good. Okay, and your knockdown resistor here for your variable output power, it looks fine, so we don't need to touch any of that. All the 10 ohms look good, no burnt 10 ohms. There is a difference between this one and this one, which tells me that these two outside transistors may have been replaced, but they are all from the same batch. You see, that's a 7G. They're all 7Gs in here. So maybe they just didn't have enough of those that type of resistor, so they just replaced it with what they had. Okay, all right, more to come. Okay, one other thing I noticed is the little insulator for your LED there has come out. So just so happens I've got a new set, so I have to take this guy loose, back him out, and I'll snap him in that new holder there for you. I did have to drill another hole here in the back because there's no way I was going to pass both of these wires through that same hole. So got that on there, got the toroids on there to keep the RF off the power cables. And yes folks, you have to do it on both positive and negative. Okay, and that's industrial hot glue holding those guys in place. Alright, that's not your hobby hot glue. That's industrial hot glue. And not the kind that they glue on cracker box tops with either. That's good heavy duty stuff. But if you want to get rid of it, just put a little alcohol on it and it'll break free. Turn loose whatever it's holding on to. Okay? More to come. Yes, sir. That little boy got hot. That was the undersides of it. There's the top of it. That's what it looked like underneath. So it got hot. Okay, more to come. Okay, this is what I was afraid of. See, I've got the scope probes connected to this resistor that was on that combiner. But you can see it's totally open. Totally open. It's a wonder this thing was even working. Make sure that I'm in the resistance setting. And I am. You can see both are connected to that, and the more that I mess with this thing, the more that stuff comes off. But it was burnt completely up. So I have to go back and look at some notes and see if I can figure out what the value is on this. I got a pretty good idea, but I want to make sure. Okay, more to come. Some of the soldering is a little sketchy, so I wanted to redo these two. I believe that wire should have been soldered to that, but it looks like there's only one strand holding it to the solder joint. The rest of it's just sticking out here in the open air. So I'm going to fix that. Okay, I think that's going to be a little better solder joint right there. And got the 47 ohm. I went back with a 5 watt instead of a 2 watt. But there's the new 47. There's the new LED holder. Okay. And this guy had the resistor here. This burn up mess. This thing here. See, when it was setting in there, it was setting like this. You could not see the burn up side of it. But as soon as I got it out and rolled it over, that's what it looked like. And of course, you can't measure it in circuit because you read a dead short because of the transformer. But once I got it out and looked at the bottom of it, I thought, how was this thing even working? But the reason it was working is because this was totally open. There's no resistance at all. And if that's a brown and a red, that means that this would be a 12 ohm resistor, which I'm almost positive that that's not the case. I'm thinking maybe it was a 120, but that doesn't make any sense either. So got to do a little research and probe some people and see if maybe somebody else has one of these and they can tell me what the value should be. Okay, more to come. I just noticed you can even see where it started burning that insulation on that wire on the combiner. Interesting. Okay. So what I believe happened, this is the wrong value. Okay, not only that, but this resistor was different than any of the other resistors in this box. So I think somebody saw that this resistor was burnt, and the original, they thought that it was burnt up, or saw that it was burnt up, and they thought they would replace it with a higher wattage, and so they probably just used whatever they had on hand, which I think was just a total wrong value for this thing. And I think that's why it got all crispy. So I replaced it with a 100 ohm 5 watt, which is what I normally do with my amps. And the 5-watt idea comes from Mr. BBI. Need to give him credit for that. He's the one that initially started putting 5-watt resistors in these things, and I think it makes a difference. So this one now has a 5-watt 100 ohm balance resistor on the output transformer. Okay, I've redone a lot of the solder joints in here. There's one, there's one, there's one. I've replaced this guy, put the bracket for that guy, but the main thing is the power cable. We've upgraded you from 10 AWG to 4 AWG. Okay. So this baby ought to scream now. Getting ready to put the connector on the new power cable and hook it up and see how it's doing. More to come. Okay, Randy, something else I discovered. These screws are loose. Not only that, but they got, well, not all of them are. That one's good and tight. But if I can loosen it with this tiny little screwdriver, it's too loose. But I'm going to go through and replace all of these because the tops are corroded. These are tight, and that one's loose. I'll have to take that resistor loose to get underneath it to check that one. That one's good and tight, but I'm probably still going to replace it because of the corrosion. I don't have any nuts that size, and that bothers me. I'm going to put new stainless hardware in this, but I won't be able to replace that nut, and that's really bugging me. I might run out to the hardware store and pick up some, but I let myself run out. Okay, more to come. Okay, one other thing that I noticed is that they were using a 2-watt resistor on your RF power control. What this guy does is he takes some of the RF and shunts it to ground. So I upgraded that to a 5-watt resistor, okay, so that it's able to handle a little more power. I know what you're going to be driving it with, so that guy right there should be able to handle everything that you put in it just fine. Okay, again, thanks Mr. BBI. Luke is very knowledgeable on amplifiers, and he is the one that clued me in on the 5-watt resistors, and I do think that it makes a difference. Okay, I don't think that we need to go to 5-watters on these. I normally put 5-watters on the ones that I build, but these should be just fine. I don't see any sign of heat damage, so I think we're good there, and we're definitely good on the input. So moving on. Not sure if I mentioned it, but got all new hardware on your transistors now, and all of the screws are tight. Now that happens with them heating up and cooling down because they are going into an aluminum heat sink. So, you know, after you run it for a while, we might want to check those screws again. You can do that yourself. Pull the cover off of it, the fan side cover, and get in there with a number 1 or read and prints, and probably a Phillips number 1 would be best. Get in there and check them, make sure that they're tight. But don't turn them hard enough to where you'll break them off. Okay, here's a view from the other side. You can see I got new nuts on there. Those are stainless steel screws, but the hardware store did not have any stainless screws that size, not even nylocks. But these are zinc plated, so they shouldn't rust. Okay, I'm replacing all the hardware with stainless hardware. I'm even going to replace these, but I don't have stainless in that length, so they're going to be zinc plated too, but I did pick those up at the hardware store. It'll have all new hardware. Okay, got brand new zinc hardware in there. The nuts, the nylon lock nuts are stainless, the nylocks, but the washers and the screw are zinc plated. Okay, now these are a little bigger than the ones that came out of there, so I had to drill the holes out just a tiny bit. I think these are 10/32. I don't remember right off the top of my head, but they're the next size up from the ones that came out of it. I think it had 8/32 in it. Oh, here, let me get one of them. I'll show you the difference in the size. Okay, that's the difference. All right, more to come. Okay, I just realized something when I powered it up. This fan is pulling air out the bottom, pulling it through here, supposedly across the heatsink and in here, but there's too many air leaks in there. So I'm going back in here and I'm going to reverse the airflow. We want this fan pulling air in from here. I want to pressurize the case, force it across the heatsink and out the back here. Okay, I just don't think that the cooling is sufficient with it trying to pull air in this way. Okay, more to come. Okay, now we're moving some air. I swapped that fan around, got it to where it's pressurizing the cabinet instead of trying to pull air through here, because we wanted to go over the heatsink. But pulling air in here and then going over the heatsink is not working too well. But if we pressurize the cabinet, the air has nowhere to get out except back here. And I've closed off that big gap that was between the PC board and the back of the cabinet using some high heat silicone, black silicone, this stuff. Same thing I use on the V998 the LC998 V1000s to close off that opening in the back of that. So yeah, we're moving quite a bit of air now. Let's see if I can find something to put there in front of it. Yeah, there you go. So it's going to need some air movement. It's going to be doing a whole lot more wattage than what it did. Alright, let me hook a radio up to it and we'll do some testing. Okay, I've got my little Cobra 18 LTD hooked up to it. Right now I'm on 12.9 volts. I'm going to move that up to about 13.8. Okay. We are on channel 20. That meter's stuck. Nope, it's just noise. Alright. Yeah, then. Oh, I got a 500 watt slug on the RMS side. I have a 1000 watt slug on the peak side. Peak is set to ×1. Okay? And you saw what I'm driving it with, just a little 4 watt Cobra 18. Okay, we're hitting almost 500 watts, maybe a little bit more, 500 watts dead key. Pulling about 65 amps. Hello audio, audio 1, 2. Pegging out the 1000 watt meter. Switch to ×2 now. ×2 means that this, where the 100 mark is 2000. Okay? Where the 40 mark is, that's 800. In between the 40 and the 60 is the 1000 mark. The 60 mark is 1200. Hello audio, audio 1, 2, 1, 2, audio. That was about 13, so about let's say 1300 watts peak. Okay. Hello audio, audio 1 2 1 2 audio, audio hello, hello audio. And it backing up on the average side is the radio, folks, not the amplifier. I can't control the output power, and it's set for like 5 watts, 4 or 5 watts. I can't turn it down. But I can turn it down on the amplifier. Let's see what that does. Hello audio, audio, hello, hello audio. Okay, that's at 12 o'clock. Let's go up to about 3 o'clock. Hello audio, audio, hello. Still backing up right there. Let's go back down to about 1 o'clock. Audio. Now that's going forward. Audio, hello, hello, audio. Okay. This is strictly a Class C amplifier. There's no bias in it for sideband. Okay. I'm going to turn the RF power on the front of the amp all the way back up. Hello audio, audio 1 2 1 2 audio, audio, hello, hello audio. It's sucking some juice. It can get some current now. Hello audio, audio 1 2 3 4 5 5 4 3 2 1 audio test. Yep, we're moving some air. This amplifier's staying pretty damn cool. So that was a good thing, what we did to move the air out of here. Want to make your amplifier last a lot longer. Okay, Randy, here it is, buddy. Audio, hello, hello, audio. Now remember, that's my radio backing up, not your amp. Little Cobra 18 LTD. I can't turn the power down on it. It's stuck at like 4 or 5 watts, probably 5 or 6 watts actually. All right. Okay, this is what it looks like on the analyzer. Hello audio, audio 1 2 1 2 audio, audio hello, hello audio. Okay, we're starting at what is that, 10 megahertz and going to 30, I think. No, we're starting at 10 going to 50. Okay, so you can see there's no spurs around it. Audio, hello, hello, audio. Audio 1 2 1 2 audio. Yeah, it's going to take that thing a minute to warm up. Okay. Spectrum analyzer. Hello 1 2 3 4 5 5 4 3 2 1. Modulation, audio 1 2 1 2 3 4 5 5 4 3 2 1. Again, that's with this little guy right here. Okay. Ready? I sure hope you enjoy your amplifier, your reworked amplifier. It was my pleasure to do that for you. 7-3, everybody. Oh, special thanks to Luke over at BBI for answering that question about the resistor value. Thanks a lot, Luke. Appreciate it. 7-3, everybody.